A cold wind blows through the lonely countryside estate. Inside, a sudden death shakes the quiet walls. A disputed will lies hidden in the shadows. Phone calls, power use, visitor logs, all hold secrets. Was it natural or something darker? Step inside with me. Together, we will uncover the truth.
Hi, welcome to this crime case. Let's solve this mystery together. We have a suspicious death, a stormy night, and a handful of suspects. Our job? Use the data to uncover the truth. Are you ready to investigate? First, we need to gather our evidence. We'll load 3 key data sets: phone call logs, power usage, and visitor logs. Each one could hold a clue. Let's see what secrets they reveal. First things first, we need the right tools for the job. Here, I'm importing Pandas, which is like our digital magnifying glass. Pandas lets us read, organize, and investigate big piles of data, just like a detective sorting through stacks of evidence. Now, let's pull up the phone call logs. I'm using Pandas read_CSV function to open a file called phone call logs.csv. This creates a variable called phone_calls. Think of it as a digital notebook where every phone call made around the time of the crime is neatly listed. We'll be able to scan through who called whom and when. Next, I'm bringing in another piece of the puzzle, the power usage records. Again, I'm using read_CSV to load up power usage.csv into a variable called power_usage. This will let us see if there were any strange spikes or blackouts. Maybe someone tried to cover their tracks by cutting the power. And finally, let's grab the visitor logs. With read_CSV, I'm opening visitorlogs.csv and saving it as visitor_logs. This file is like the guest book at the scene. It'll tell us who came and went, and exactly when. With all 3 datasets loaded, we're ready to start connecting the dots. Now let's dig deeper into the phone call logs. Calls can reveal alibis, motives, or even secret plans. Let's see who was talking to whom and when. Let's start by typing phone_calls. This is our first clue. It's a variable, which in Python is just a way to store information. Think of it like a labeled folder where we'll keep all the records of phone calls made around the time of the crime. We'll dig into this data to see who was talking to whom and when. Every good investigation starts with the basics. And in this case, it's the phone_calls. Look closely at these call times. Edith called the doctor at 7 in the evening and her lawyer just after 8. The nephew made a call to an unknown number at 8:15. These times might be important. Let's keep them in mind as we continue. Now, let's check the power usage in the estate. Unusual spikes could mean someone used a device or tried to cover their tracks. Let's see what the data tells us. Let's have a look at the power usage data. We want to spot anything out of the ordinary, especially in this study where Edith was found. Alright, first up, I'm typing in power_usage. This is our starting point, a variable that'll hold the data about how much electricity was used at the crime scene. In Python, a variable is like a labeled box where you can store information, and here we're getting ready to see if someone's late night activities left a digital footprint in the power records. Let's see what secrets this variable might reveal. We have power usage for each room. To analyze the timing, we'll convert the time column, called time_, into a datetime object. This helps us match events to exact moments. First up, we're converting the time column in our power_usage data into a proper time format. In Python, we use Pandas to underline datetime function for this. It helps us turn those hour and minute strings into actual time objects. That way, we can spot exactly when the lights flickered or the power spiked. Crucial details for our timeline. Now let's take a look at the power underline usage data frame itself. Think of this as laying out all the raw evidence on the table. Every timestamp, every reading. We want to see if anything jumps out, like an unusual surge or a blackout that could hide someone's movements. Notice the big spike in the study's power usage at 8 o'clock. It jumps to 1.5 kilowatts. That's much higher than usual. Something happened in the study at that time. Could this be our turning point? Let's make this clue even clearer. We'll plot the study's power usage over time. Sometimes a picture reveals what numbers can't. First things first, we need our investigative tools. Here I'm importing matplotlib.pyplot as PLT and datetime. Think of Matplotlib as our crime scene sketch artist. It'll help us visualize the evidence. And datetime, that's our timekeeper, letting us track every moment in the timeline of the crime. Now let's set up the timeline. I'm creating a variable called times. That's just a name we give to hold our list of time objects. Using a list comprehension, which is a quick way to build a list in Python, I'm taking each string like 18, show, 19, and so on, and converting it into a real Python time object using datetime.startTime. This way, we're not just looking at text, we're working with actual times, ready to spot any suspicious activity hour by hour. Alright, let's prepare our canvas. With plt.figure and fig size set to 8x4, I'm telling Python to make a wide, clear space for our chart. Think of this as rolling out the evidence board in the detective's office. We want plenty of room to pin up our clues. Here comes the real action, plotting the data. I'm using plt.plot to draw a line showing how much power was used in the study at each hour. The x-axis is our list of times, like 18 chows and 19 chows, and the y-axis is power underline usage underline kW. That's a variable holding the power readings. The marker equals O means we'll see dots at each point, and color equals red makes the line stand out, just like a trail of evidence. Let's give our chart a title so we know exactly what we're looking at. With plt.title, I'm labeling this plot as Study Power Usage Over Time. This way, anyone glancing at our evidence board knows we're tracking the study, the very room where the crime might have happened. Next, I'm labeling the x-axis with plt.xlabel. This tells us that the bottom of our chart shows the time, so we can see exactly when things started to look suspicious. And for the y-axis, plt.ylabel makes it clear we're measuring power usage in kilowatts. That's the unit for how much electricity was used. If there's a sudden spike, it could be a clue. Maybe someone turned on a device at just the wrong moment. To make sure we don't miss a single detail, I'm adding a grid to the chart with plt.grid set to true. This draws faint lines across our evidence board, making it easier to line up the times and power readings. Every detail counts in an investigation. Finally, plt.show brings our chart to life. The evidence is up on the board for everyone to see. Now, with the timeline in front of us, we can start searching for the moment when everything changed. The chart shows a sharp spike at 8 o'clock. This is where things get interesting. What caused this surge? Let's find out who was in the house at that moment. Now, let's review the visitor logs. Knowing who was present and when can help us narrow down suspects. Let's see who had access to the study during the power spike. Let's start by pulling up the visitor underline logs. Think of this as our master guestbook. Every person who stepped into the scene of the crime is listed right here. In Python, when you see a name like visitor underline logs, that's a variable. It's just a label we use to store and refer to our data, so we don't have to keep typing out the whole thing every time. This is our first clue. Let's see what secrets it holds. From the logs, we see the nephew and housekeeper were both present at 8 o'clock. The doctor had already left. Only these two could have been involved when the power spiked. the plot thickens. Let's cross-check the call logs with who was present. We'll filter for calls made between 7:30 and 8:30. This could reveal more about what happened during the power spike. Alright, before we dive in, let's set the stage. We need to work with the times of each phone call, but right now they're just plain text. So let's convert those times into something Python can actually understand: real date and time objects. That way, we can filter and compare them like a pro detective. Here, I'm creating a new column in our phone calls data called time_dt. That stands for date time. I'm using Pandas, that's a Python library for handling data, and it's to underline datetime function. This takes the time from each call, like 1945, and transforms it into a special datetime object. Now, Python knows these are actual times, not just words. This is crucial for our investigation because we'll want to zoom in on calls made during a very specific window. Now, let's get strategic. I'm filtering our phone calls to find only the ones that happen between 7:30 and 8:30 p.m. That's 1930 to 2030 in 24-hour time. I'm creating a new variable called filtered_calls. This line uses a logical condition. It checks if each call's time _dt is greater than or equal to 1930 and less than or equal to 2030. Only the calls that fit this window will make it through. Think of it like sifting through security footage for just the right hour. We're narrowing down the timeline to when something suspicious might have happened. Let's take a look at what we've found. By typing filtered_calls, we're asking Python to show us just the calls that happened during our window of interest. This is our shortlist, the calls that could hold the key to cracking the case. Let's see who was talking and when. Between 7:30 and 8:30, the housekeeper called the police, Edith called her lawyer, and the nephew made a mysterious call. But the lawyer had already left. Was Edith's call real or staged? This detail could be key. Now, let's put it all together. The power spike in the study at 8 o'clock is suspicious. Only the nephew and housekeeper were present. The nephew made a strange call right after. Edith's call to her lawyer doesn't add up. Based on the data, the nephew had motive, opportunity, and suspicious behavior. The evidence points to him as the likely suspect. Great work, detective. Have we cracked the case, or is there more to uncover?